Hello everyone, my name is Paul and welcome to another video of the data structure playlist. Here in this video, we are going to talk about the deletion in heap. Okay, in the last video, I have discussed about the insertion in heap, how we will be inserting elements in the heap. But in this video, we are going to discuss about the deletion part. Okay, so deletion in heap. Okay, that is the bottom line. Okay, so like any node can be deleted. Okay, from the heap, any node you can delete, but the deletion of root actually is a little bit more important. Actually, it's not little bit, actually it's much more important to understand how actually the root node will be deleted. Okay, here obviously this is the root node, correct? So deletion of this root node, we have to understand how it would be happening. Okay, why it is important, you can ask that one also. See, as we are implementing the heap using array, so any node can be deleted. Even using linked list also, we can find that node and we can delete it. That's not a problem. But deletion of root node is important, as during max heap, okay, during like max heap, okay, the root will be the maximum element. Root will be the maximum element, and during mean heap operations, okay, the root would be the minimum value of the entire heap. Now, why we are using max heap, minim? What is the purpose of heap actually? When I have started the heap video, I told you guys that it is mainly used to extract the maximum minimum element from a list of, or from a bunch of nodes or elements or numbers, correct? So the application of heap actually based on its getting the maximum and minimum value in a faster way. That it will be O of n log n, sorry, O of one time complexity. I'm really sorry, O of one time complexity. Okay, that's why we are using heap. Otherwise we can use any data structure to get any maximum element deleted, correct? Why we are using it? Because it's the faster way to get it. So that's why deletion of root is important. Okay, now tell me one thing, if I would be deleting this root, okay, now who will take the place? That is the problem which will be occurring. Who will take the place? Obviously the last one. This is the rule, the last one will go, because we don't know which one is greater than this. We don't know, okay, which one is greater than. That's why last one will be going here, and based on that, like, the comparison will be happening, and after that, okay, the deletion will be happening. Okay, so once like like we can place this 38 there. Okay, so what will happen? It will be 38 and this will be deleted. Now what will happen? 38, like, how, who will replace 38? Obviously, correct. Now who will replace 38 among like 59 and 45? Who will replace? Obviously 59 will replace, because these both of them, who is greater than? 59 is greater than 45, so 38 will be coming here and 59 will be going here. Okay, after that what will happen? After that it will be compared with 46. Why 46? Because 24 and 46 may 46 is greater than that, so obviously 38 and 46, so 46 will be coming here and 38 will be coming here. Now is there any further child node here? No, so though it is stopped. So that will be the uh, result, that will be the result after the deletion operation of the root in this max heap. That is the basic thing. Okay, let me give you another example. Okay, let me give you another example where, like, for example, the this one will be, okay, 90, then 70, then 80, then 24, then 59, then 45, 12, 14, 10, 38, 46, 32, 37. Okay, for example. So now what we will be deleting? We will be deleting this one, correct? Now what will happen? Okay, so 90 will be deleted. Then 37 will go and take the place. So obviously what will be coming, like let me copy it. So what will happen? It will be 37. Now among 70 and 80, who will take the place of 37? Obviously 80 will take the place. So here 37 will be happening and here 80 will be there. Again 37, who will take the place? 37 is not greater than both of them. So obviously 45 is greater. So obviously 45 we will take here and 37 we will take here. Okay. Then 37 and 32, okay, these are fine. So now it is sorted. So that is how the deletion will happen in this place as well. Okay. Okay, now uh, after deletion, okay, if you delete each and every node like this, okay, what we will get? Okay, like for example, you have built the heap, okay, or the elements are there, you have built the heap, okay, and after that what will happen? Okay, by the way, in the last video I told you guys about the build heap method, right? It will take O of O of n log n time complexity. Okay, best, average, or worst, whatever you can say, it will be O of n log n time complexity. Why? Because one place, okay, one element, okay, will take the place, okay, another one will come, and then reshuffling is happening. So every time, like O of O1 is there for insertion, and after that O of log n is there. Correct. So total time is O of 1 plus O of log n. This is happening for n elements. That's why n log n time complexity is there to build the heap. Okay. Now here, after the deletion operation also, okay, so deletion operation also will take the same thing only. Okay, it will take O of log n time complexity, okay, for deletion also. Why? Because obviously you will be putting it here again, it is coming like this. So maximum height is possible, maximum length is possible, what? The height. So that's why O of h, okay, O of h, which means O of log n time complexity for deletion as well. Got it? So that is the thing. And if I talk about like after deletion, like if you delete, what I was saying, that if you delete, for example, first element has been deleted, okay, what is coming? O of log n time complexity. Okay, log n time is needed, plus again, okay, another one you are deleting. So obviously this time it will be deleted 80, 32 will be going there, then this will come in here, this will come here, this will come here. So 32 will be here, 46 is here, 59 and 70 will be there. Again 70 will be deleted, again anything will happen. So every time O of log n time complexity we have to consider. Okay, every time. How many times? Obviously n times, because there are n number of nodes. So total entire, like n2, if you want to clean the entire heap, what is the time complexity? Obviously O of n log n. Okay, now tell me one thing, if it is the total time complexity, what will happen after every deletion? What will happen? Okay, so we got 90, 90, 80, then 70. Okay, this gone. Okay, then again what will happen? 59 will be coming up. Okay, then what will happen? 46 will go. Okay, then 45 will go. Then obviously I think 45, 46 gone. Then I think 38 will go, because obviously based on the comparison it will be go, the maximum element will be going up and up and up. Correct. 38, then 37, then 38, 37, then it will be 32. Okay, it will be 32, then it would be 24, then it would be 14, it would be 12, it would be 10. Okay, just like that. If you see the pattern here, this is in a decreasing order, it will happen. I will show you in the heap sort video. I will explain. I'm just giving an example. If you delete one by one, so how many elements you are having? N elements. For deletion of each operation, deletion of each element, what is the time complexity? O of log n. For n elements, it would be O of n log n. So that is the time complexity of heap sort, and the sorting is done in the decreasing order. If you want to have the increasing order, then you have to use a mean if. That's it, nothing like that. Okay, so that is called actually heap sort. Okay, so we will talk about heap sort later on, don't worry about that. But yeah, this is all about the deletion operations. In the next video we are going to talk about the coding part. So yeah, let's get into the VS code, and in the next video we will talk about it. Okay, if you are liking the videos, please hit the like button for sure, and let me know in the comment section if you are not understanding anything, if you need any external help, so we can connect on Google Meet, and we can discuss. Okay, if you need any help, then yeah, let me know in the comment section. If people are more, then we will definitely, we can have some sessions, okay, extra, if you're not understanding anything. Okay, so yeah, this much for today guys, and see you in the next video. Thank you so much.